Okay, Assalamualaikum and good morning everyone. Okay, so let's continue our lecture with the very last subtopic for chapter 7. Okay, so today is about Doppler effect, right? So by the end of the lesson, you should be able to state what is Doppler effect for sound waves, then apply the Doppler effect equation. This is the equation for relative motion between source and observer. Okay, and then remember for your syllabus, the questions will be limited to stationary observer and moving source or vice versa. Okay, meaning that we are looking at two things. The first is the observer, the next is the source of the sound. Okay, so your questions will involve only one of these moving. Another one will be stationary. Okay, you will not get any questions where both of them are moving. Okay, so it will be easier for you to answer for your PSVM. Okay, because only one is moving, another one is stationary. Okay, so the first slide, what is Doppler effect? So by definition, Doppler effect is defined as the change in the apparent frequency of a wave as a result of relative motion between source and the observer. Okay, because there is a relative motion between the source and observer, the apparent frequency changes. Okay, so when a source of sound is moving towards an observer, okay, bayangkan ambulance moving towards you as the observer. So the pitch the observer hears is higher than when the source is at rest. Okay, when the source is travelling away from the observer, the pitch is lower. Okay, so bila ambulance tu is moving past you, so the pitch is lower. So this phenomenon is known as the Doppler effect and occurs for all types of waves. Okay, next slide is about the explanation of Doppler effect phenomenon. Okay, the first, when there is no relative motion between the source and the observer, all observers hear same frequency. Okay, so now the source is stationary and the observers are also stationary. Okay, because there is no relative motion, there is no changes to the wavelength. Okay, so the wavelengths remain the same for every observer. But then, if there is a movement of the source, it will alter the wavelengths and the received frequency of sound even though source frequency and sound's wavelengths are unchanged. Okay, so let's say we are referring to the fire truck. Okay, the source frequency from the fire truck will remain from the beginning till the end, constant. The same for the sound velocity. But because of the movement of the motion, this will alter the wavelength. So you see here, the wavelength is larger compared to the right hand side. Okay, so point number 3, as the source moves away from the observer, the same number of waves are expanded to fill a larger distance. Okay, so according to the formula V equals to F lambda, when V is constant, okay, and then from here we know that the F is inversely proportional to the wavelengths. If the wavelength becomes larger, meaning the observer will hear sound of longer wavelength, lower frequency or lower pitch. Next, point number 4. As the source approaching observer, the same number of waves are compressed. Okay, so here we can see the wavelength becomes closer to each other. Okay, so the same thing as V constant, the F is inversely proportional to the wavelength. When the wavelengths become closer, so the frequency heard by the observer is a high frequency, a higher pitch. Okay, or maybe you can just think logically, when the fire truck is moving away from you, so the frequency that you can get or the frequency you can hear is a lower frequency. But then if the ambulance is approaching you, if the siren is approaching you, logically you will hear sounds with higher frequency with a higher pitch. Okay, so the next slide is about the equation of Doppler effect. Right, so the formula is Fa equals to V plus minus B naught over V minus plus Bs. Okay, so V is the speed of sound. This is usually a constant, will be provided in the question. Vs is the speed of source, let's say the siren, the bell. Next, V naught is the speed of observer. Okay, FA is the apparent frequency or observed frequency, and then F is the frequency of the source or actual frequency. So actually there is a F over here. Okay, so the right formula is this one with the F. Okay, what is the F again? So the F is the frequency of the source. Okay, so the plus minus sign can depends on the information given in the question. Okay, so let's say this is the formula, and I mentioned earlier in the first part of the video that your syllabus will be limited to the case where one of the two things will be stationary, either the observer stationary or the source stationary. So let's say if the question is about stationary observer, so here the V naught will equals to 0. So we can take out the V naught from the equation. Okay, and then the same thing, if the question says that the source is stationary, so Vs now is equal to 0, so we can take it out from the formula over here. Right, so we have 4 different situations for Doppler effect, where one of the two things is stationary. Okay, so let's see the first case. Here, the source moving away from a stationary observer. So the stationary observer meaning the V naught is equal to 0. Okay, so make sure in the formula over here there is no V naught. Then, logically thinking, when the source is moving away from the stationary observer, so the apparent frequency received by the observer will be decreasing. Okay, so in order to get decreasing FA, so the denominator should be increases. Okay, for that we need the positive sign. Okay, bila bawah ni tambah, barulah denominator akan increase. So the apparent frequency decreases. Okay, so the next case is the source approaching or moving towards a stationary observer. So again, stationary observer, so V naught is equal to 0. So we can take out the V naught from the equation. So the source now is approaching the observer. So the apparent frequency here by the observer will be higher. So for that to become higher, so this part over here should be decreasing. So we need the negative sign. Okay, next, the third situation is the observer moving away from a stationary source. So now the stationary source, meaning the Vs is equals to 0. So we don't have to put the Vs in the equation. So this one no need. And as the observer is moving away from the stationary source, so the apparent frequency received by the observer is decreasing. So for that to become decreasing, the numerator should also be decreasing. So we need the negative sign over here. Okay, so the next situation is the observer approaching a stationary source. So stationary source, again, the Vs is equal to 0. So no Vs in the equation. And then the apparent frequency should be increasing because the observer is approaching the stationary source, mendekati source. So for the Fa to be increasing, the numerator should be with the positive sign to make it increasing as well. Okay, and then if you look at in the slides, so there is a method called the OS method. So maybe you can try to read this one. This is like a method on how to get the right equation easily. Okay, so you just have to go through the notes. Okay, so here is the first situation. Okay. Second, third, and fourth. Okay, so let's take a look at one example for Doppler effect problem question. Okay, so a train moving at constant speed 20 meters per second. Okay, so the train is moving. Here we have a train moving with 20 meters per second towards a stationary observer. So the observer is standing at the platform. Okay, so for stationary observer, V naught is equals to 0. The moving train produces a loud sound signal at frequency 500 Hz. So the source of sound is the moving train. So F source is equals to 500 Hz. Okay, so the train is making a sound. Determine the frequency of sound heard by the observer. So basically you need to find the apparent weight. So FA of the observer when the train moving towards the observer, mendekati. So logically the sound will become louder. Okay, so the FA we can expect it to be large. So these are all the information from the question, and the formula for Doppler effect is FA equals to V plus minus V naught over V minus plus Vs times with the source frequency of the source. Okay, so for our case right now, the observer is stationary, so V naught equals to 0. We can take out this one. Okay, and then logically the FA should be increasing. So for that, the denominator, this part should be decreasing. So for that to be with a smaller value, we need the negative sign. Okay, so V minus Vs, the value will become smaller. So the FA will be increasing. Okay, so just substitute the value. The speed of sound is given in the question 340 meter per second. So 340 minus 20. So the frequency of the source is 500. So the apparent frequency received by the observer is 531.3 Hz. Okay, so this is the original frequency from the source, but the one received by the observer is higher. Okay, so this is because of the Doppler effect. When there is a relative motion, the movement will change the wavelengths. So the wavelengths is inversely proportional to the frequency received by the observer. Okay, so that's all for our lecture. You may continue with the exercise question. Thank you.